Good morning, everyone. So, welcome to my YouTube channel, Max Avatarm. So, today we are going to see fifth lecture on functions of bounded variation. Till now, if you have not subscribed my YouTube channel for such type of interesting topic, subscribe it immediately. Okay. So, let's start today's lecture now. Okay. So, we will prove this theorem. Let A and B belongs to real number such that A is strictly less than B, then any polynomial defined on closed interval AB is a function of bounded variation. So its proof is simple. Okay. So if I take fx is equal to x, fx is equal to x, if I am taking function fx is equal to x, okay, then f is monotonically increasing function on you take any interval, it is monotonically increasing. We know that every monotone function is function of bounded variation. We have already done this question, this result, that every monotone function is a function of bounded variation. Okay. So f is function of bounded variation. Okay. So this implies f is function of bounded variation bounded variation on AP. Okay. Because every function monotone function is function of bounded variation. Okay. Now take let P, sorry, if fx is equal to x is function of bounded variation, then by in last lecture we have studied that then fn x is equal to x to the power n. I can write it f into f into f up to n times. I can write n times. So this is nothing but f to the power n x function. Okay, so this implies fn is equal to f to the power n is also function of bounded variation, because product of function of, suppose you have a function of bounded variation, then their product will be also functions of bounded variation. So product of functions of bounded variation is function of bounded variation. So so this implies so this implies so then this implies fn is equal to x to the power is a function of bounded variation on AB for any natural number. You take any n belongs to n, x to the power n is function of bounded variation. Okay. Now take any polynomial. Consider the polynomial of degree k. We are taking polynomial of degree k. Okay. Then so consider the polynomial of degree k. Px is equal to a naught x to the power k plus a1 x to the power k minus 1. Okay, like that. Okay, so this is a1 a n minus 1 x plus a n. Okay, now you see that consider this polynomial. So how I can write? This is a constant. So this is a constant. So I can write px is equal to a naught f k x plus a1 f k minus 1 x. Okay, and this is a k minus 1 fx plus f. Here is not n minus k, it is here k minus 1. Okay, k minus 1 a k. So where I can write okay a k. Okay, now you see that each, let's say this equation number 1. So uh, each fk each fk minus 1. Okay, and this is f1 f1 are functions of bounded variation Okay, fk minus 1 f to f1, because they are nothing but fk is x to the power k power, fk minus 1 is x to the power k minus 1 power. Okay, f1 is x is equal, f1 x is nothing but fx. Okay, but these are functions of bounded variation. Now uh, let f naught x is equal to ak, then this is a constant function. Constant functions is constant functions are functions are functions of bounded variation. So this implies f naught. So this implies f naught is also function of bounded variation. Okay. Now, because each fk minus 1, fk minus 2, f2, f1, okay, f naught are functions of bounded variation. If we take scalar multiplication of functions of bounded variation, then that is also functions of bounded variation. This implies if I multiply here by a naught fk and a1 fk minus 1, a2 fk minus 2. So here what I will do, it will be ak minus 2 k minus 2 f2 ak minus 1 f1, and I will keeping f naught as it is, because taking scalar multiplication of functions of bounded variation, still it is a function of bounded variation. So are functions of bounded variation. Okay, so this implies their sum of functions of bounded variation is function of bounded variation. Is also function of bounded variation. And you see that this is nothing but, what is this? This is nothing px. This is equal to px, p polynomial. So this implies p is function of bounded variation. Okay, so we have shown that. So this implies polynomials are functions of bounded variation on closed interval A. So in this lecture, we have shown that polynomials defined on any closed intervals are functions of bounded variation. Okay, we will use this fact later. So thank you very much for today's lecture. If you have any problem or issue related to this lecture, you can comment me on my YouTube channel. Thank you very much for today's lecture. Thank you very much. We will see you in next lecture. Thank you very much. Like, share, comment, and subscribe my YouTube channel. So thank you very much.